If you're shopping for a solar installation or considering going solar yourself, one of the most common questions is how much energy will the panels generate? This is easy enough to answer when you know the details. Today, we'll show you how to calculate solar PV energy output step by step with a simple method for beginners, plus a free tool that'll do it in seconds. Let's dive in. What determines PV energy output? Well, let's draw a little concept map. At the top, we have inputs like location, mounting, system size, and losses. At the bottom, we have the annual energy in kilowatt hours per year and the monthly shape. In between, we have a system block. And knowing these three things, we can go from inputs to output. The rule of thumb is more sun, better orientation and tilt, and fewer losses equal higher kWh per kilowatt peak, and vice versa. So we'll go through each one. First, location. For solar energy, we care about irradiance, either global horizontal or direct normal, which is fancy language for sunlight. If you live in the northern hemisphere, it's pretty straightforward. You get the most sun in the summer, less in the fall and spring, and the least in the winter. And of course, don't forget the time of day. You get tons of sun at noon and very little in the early morning and late afternoon. Note that these diagrams are for 40 degrees north latitude, but every degree of latitude matters. So be sure to grab the appropriate value for your location. If you're not sure, don't worry. We'll talk more about this later. Next, mounting. Now you've got some decisions to make. Did you decide on ground or rooftop? This choice impacts shading constraints, the layout of your array, and the hardware required to build it. Each of these options has their own pros and cons, which we're going to skip over for now. If you'd like us to make a dedicated video on this topic, let us know in the comments below. Once you know whether you're doing a ground or rooftop project, then you'll want to figure out the tilt and orientation of your array. And again, there are a lot of choices here. For ground installations, we have three main options. First is a fixed south array. This means the rows of modules are mounted facing south with a tilt that matches the local latitude. This is typically the simplest and least expensive option, but it also produces the least energy compared to the other options. The next option is a horizontally mounted single-axis tracker, or HSAT. With an HSAT, the axis of rotation runs north-south, and the modules face east in the morning and west in the evening. A tracker is the most complex option, but it can also produce the most energy. And if you want even more energy, you can add backtracking, which we'll talk more about soon. The last option is a fixed east-west array. This isn't as common as the other two, but it's a great option if you're tight on land because it fits approximately 1.5 to 1.8 times more panels compared to fixed south. However, as the name suggests, it faces east and west, so the modules will receive less sun compared to south-facing panels. We recommend a tilt of roughly 10 degrees for all east-west arrays to help with drainage and snow shedding. Note that the optimum tilt varies as you move away from facing south, but our goal is to keep things as simple as possible. Also, we strongly encourage you to watch our video on the importance of tilt in PV systems. It'll teach you why tilt matters and how to think about it. Now for rooftops, we have four main options. Since you're usually limited by the shape of the roof and structure, you'll probably need to install multiple arrays, so you'll have to play around with orientation and tilt to find what works best. But there are some rules of thumb that should help speed up your analysis. Fixed rows of modules, ideally facing south. Fixed east-west modules for compact DC layouts on flat roofs. Flush mounted parallel to the pitched roof for south, east, or west orientations. And finally, we have north-facing, which we generally don't recommend because you get very little sun on a north-facing roof. As with ground mountings, the tilt for each array will depend on its orientation and the goals of the project. Again, we strongly encourage you to watch our video on the importance of tilt in PV systems. It'll teach you why tilt matters and how to think about it. Okay, now we're ready to talk about tilt. Our rule of thumb is to start with your local latitude plus or minus 10 degrees and then tweak based on your goals. Higher winter yield, try a higher tilt. Summer peak, try a lower tilt. The tracker adjusts for sunlight angles and uses backtracking to dodge midday shade. Irradiation data. Where and what to grab. Grab your solar data from a public site like PVGIS or NREL PV Watts. You'll get info on yield per kWbp of DC and irradiation, plus monthly and yearly stats. For better accuracy, use Google Maps for your exact location. When picking panels and inverters, go for a solid Tier 1 brand with 400-600W for residential or commercial use and 500-650W for utility. Check key specs like VOC, VMPP, ISC, MPP, and size. Remember, real voltages drop at higher temps. Inverters come in two types: string, for homes and commercial use, and central, for utilities. Check the max DC voltage, MPPT voltage range, max DC current per MPPT, number of MPPTs, and AC power. A good starting DC-AC ratio is between 1.0 and 1.3. For quick checks, ensure the Max series modules are right for cold conditions and the MIN for hot ones, while keeping ISC times parallel strings within MPPT limits. Losses and performance ratio, PR. Typical first-pass PR is around 0.80. Here's a quick breakdown. Inverter and wiring, 2 to 4%, temperature, 4 to 8%, soiling, 1 to 5%, mismatch and degradation, 1 to 4%, availability, 0 to 3%. Adjust PR as you learn more about your site. Calculation you can do today. Gather your data, latitude, longitude, mounting tilt, orientation, kWp, annual irradiation or kWh kWp, and PR, 0 to 80. The formula is simple. Annual energy, kWh, irradiation x system size, kWp x PR. For example, 10 kWp x 1700 kVArt kWp x 0 to 80 equals 13,600 kWh year. Plus, HSAT might boost yield compared to fixed south, and EW setups can help with limited space. Fast path with PVToolBox, free and pro. Check out PVToolBox.eu. It's a free calculator where you can just paste your Google Maps coordinates, pick your mounting type, and get instant annual and monthly results. The Pro version lets you add custom loss profiles and export reports, saving you hours of work in just minutes. If this helped you out, give us a like and subscribe for more awesome PV tips. Don't forget to check out the free calculator at PVToolBox.eu, links in the description, and explore the Pro edition for advanced projects.